Hello, my friends, and welcome back to the You Can Do TV channel.
In Mazowiecki, the Jutrenka two-wooden house rises steadily, each beam and panel finding its place in the growing structure. The early assembly shows just how much planning goes into each module. The wooden frame almost breathes life into the blueprint, forming a home from raw timber. The foundation is carefully laid and checked for level, forming the stable base required for the entire structure. Even before the walls appear, the precision in alignment is obvious. Subcontractors ensure concrete and footings are exactly as specified, providing a platform that will support the full weight of the house without settling or shifting. Those footings are deceptively strong for such a light-looking structure. Once the foundation is complete, the DREWNEX-supplied wooden frame is positioned. Vertical and horizontal beams are raised, locked into place, and reinforced to form the skeletal walls and roof supports. Those beams hold more than weight. They frame a living space designed for comfort and durability. Workers use cranes and manual adjustments to carefully align every element, preventing misfits or gaps. With walls erected, roof trusses follow. Panels and covering materials, also from DREWNEX, are installed thoroughly, forming a protective and visually coherent top. The trusses are spaced and secured so that the roof resists weather while maintaining the design integrity of the house. Temporary braces keep everything steady as the roof gains form. Never thought prefabricated wooden roofing could be handled so smoothly at this scale. Next, windows and doors are inserted. Carpentry teams fit each DREWNEX-provided frame precisely, ensuring snug installation and airtight seals. Proper alignment not only enhances insulation, but also maintains the wooden aesthetic of the house. That fit looks surprisingly seamless for prefabricated wooden components. Even slight shifts are corrected immediately, showing real craftsmanship. Throughout the assembly, prefabricated modules and sections provided by DREWNEX allow faster and more precise work. Teams focus on positioning and securing rather than cutting raw timber on site, reducing errors and improving speed. The efficiency makes the site feel less hectic than expected. That speed alone could catch anyone off guard. Exterior touches are added, including porches and additional roofing extensions. The house stands complete, structurally stable, and visually harmonious, prepared to withstand years of use. Even the smallest fittings are adjusted for perfect alignment. The joint work and fit are details that always surprise, demonstrating the reliability of prefabricated wooden construction. Concurrently, insulation work transforms this recreational cabin into a year-round home. Panels and layers are installed inside walls and ceilings to ensure efficient thermal retention. The attention to insulation makes the house feel almost alive, reacting intelligently to seasonal changes. Insulation panels slide in like puzzle pieces, no forcing required. Specialized subcontractors handle electrical wiring, plumbing, and other internal systems. Conduits, pipes, and cables are integrated with care to avoid interference with the wooden structure. The coordination between wood framework and technical systems is remarkably smooth. From foundation to final finishing, every step integrates craftsmanship with prefab efficiency. DREWNEX's delivery of frames, roofing, and joinery, combined with skilled assembly, illustrates modern wooden house construction at its finest. The whole process unfolds with a rhythm that feels almost unstoppable, like the structure itself anticipates each step. That attention to detail is truly something. Painting begins once panels and frames are secure, adding protection and aesthetic appeal. Exterior walls receive coats of weather-resistant stain, while interior wooden surfaces are treated to highlight natural grain. The color change is subtle but gives a refined finish. The painted surfaces now gleam under sunlight, signaling readiness for occupancy. Even for operators and builders new to the system, the workflow remains smooth thanks to modular design and clear assembly sequences. Each module fits naturally, making the construction process almost intuitive. Adjusting small panels for perfect alignment shows dedication at every stage. By the end, Utrzenka 2 stands as a year-round wooden home, blending practicality, aesthetics, and durability. The way everything locks into place gives a sense of calm power. The final sight of the completed house leaves a real sense of achievement. Feel the precision as the Gablock crew prepares the wooden floor grid for the insulated blocks. Each square cavity is thoroughly arranged, providing the base that will support the modular walls. The way the crew handles each panel makes the whole floor feel like a giant puzzle coming together. Once aligned, the team secures the floor frame to the foundation using the Gablock starter rails. This ensures the structure will remain stable during the wall assembly. That base looks sturdier than it seems, almost like it could hold twice the weight. Next, the insulated Gablock blocks combining OSB and EPS are positioned carefully onto the floor grid. The interlocking design allows them to fit snugly together, forming the skeleton of the walls. Blocks slide in seamlessly, showing the efficiency of the interlocking system. Seeing the blocks slide into place this smoothly is oddly satisfying, each one locking perfectly. Crew members use a cordless drill to fix the blocks temporarily, maintaining alignment before adding vertical battens every 40 centimeters. The team continues building the wall layer by layer, inserting the blocks row after row. Each block is pre-measured, so the openings for doors and windows are already defined. Every row lines up like clockwork, no guesswork needed. It's impressive how clean and organized the layout looks at this stage. Any small adjustments are made using the integrated Gablock system spacers to maintain exact vertical and horizontal alignment. This ensures thermal efficiency and a straight, level finish. After completing the wall layers, the crew places the top rail across the last row of blocks. This rail unifies the structure and provides anchoring points for the roof or next construction phase. The battens continue to secure the walls while leaving mechanical gaps for wiring or plumbing. This setup feels like muscle and intelligence packed together. The crew double-checks every joint, making sure that the modular skeleton is fully stable and perfectly square. Each joint checked here confirms the strength of the modular system. Finally, the completed floor and wall modules stand ready for the roof installation. It's surprising how quickly the structure is ready for the next phase. The integrated insulation within each block guarantees both thermal performance and soundproofing. The day ends with a solid shell prepared for finishing touches, doors, windows, and external siding. You'd never guess that rough timber blocks could assemble so efficiently. This is why modular construction with Gablock is considered fast, practical, and reliable. Giant wooden beams are lifted carefully, each piece forming part of the roof structure with deliberate precision. The way the crew maneuvers these massive timbers makes you realize the skill involved in every placement. On this construction day, the framework for the roof of the model house begins to emerge, revealing the skeleton that will soon support tiles and insulation. Feels like watching geometry come alive in 3 dimensions. Each truss placement is timed perfectly with the crane's movement. Team members coordinate as each beam is hoisted into place by cranes and guided into exact alignment. Temporary braces secure the structure while the next set of trusses is prepared. That pull from the crane looks stronger than expected for a mid-sized machine. Angles are checked continuously to maintain proper pitch and slope. Safety measures are integrated seamlessly, and crew members double-check each connection point. Bolts and brackets are fitted with surprising efficiency. The beams lock together more smoothly than expected. The precision and positioning without overcomplicating things is impressive. Each adjustment is subtle but crucial for overall stability. The coordination at this height really emphasizes skill under pressure. Watching the team anticipate each move is like seeing a well-rehearsed sequence unfold. Once the main trusses are in place, secondary beams are added to reinforce the structure and provide support for the roof decking. Workers climb scaffolds carefully, using power tools to secure bolts and brackets that lock the framework together. The framework seems to grow almost organically as beams interlock. Seeing the trusses connect like this gives a real sense of structure forming. The way the team moves as one unit makes the whole site feel synchronized, without needing constant instruction. With the framework stabilized, purlins are installed horizontally across the trusses, creating the foundation for roof tiles. This step demonstrates how modular planning and traditional carpentry merge efficiently. Never thought setting horizontal supports could look so smooth and controlled. Openings for skylights are incorporated into the frame, ensuring that each structural element has its place. Even minor adjustments are done without halting progress. You wouldn't expect such heavy beams to be positioned with such apparent ease. Each purlin is leveled and checked with laser tools for perfect alignment. Temporary supports are removed gradually as the structure proves its stability. The roof is starting to hold itself up even before final fixtures. Precision in these horizontal beams shows the value of planning ahead. Finally, additional bracing is added to corners and ridge lines to guarantee resistance to wind and load. Crew members verify that every bolt, joint, and truss meets the design specifications. That final check ensures the structure will endure long-term. How these enormous wooden beams are held with such apparent ease and balance. By the end of the day, the roof frame is fully assembled, giving the house a clearly defined silhouette. The final silhouette reflects both engineering and craftsmanship. That coordination between cranes, crew, and the wooden structure makes the complexity look almost simple. This day highlights not just the speed of assembly but the careful engineering behind each beam and connection. Every piece seems to find its perfect place naturally. It's rewarding to see every component working together as designed. Sandwiching foam inside concrete is a unique technique Bob Moore Construction uses for tilt wall panels. First, workers position a wood form precisely to shape the panel matrix. That layering order is surprisingly clever. Rebar is placed in the form, then a partial concrete pour covers it, forming a solid base. Immediately, rigid foam insulation is laid on the wet concrete. Each piece is cut and numbered to fit like a jigsaw. The coordination between crews is sharp. Timing is everything here. Fiber composite connectors are inserted through insulation into the first concrete layer to permanently attach the insulation. Once cured, additional rebar is added before the final concrete layer is poured and smoothed. Panels are then left to cure completely. The result is a robust insulated tilt wall panel capable of maintaining interior temperatures in temperature-controlled buildings. Finally, the panels are lifted into place using cranes, forming walls that are both structural and thermally efficient. That placement looks easier than it actually is. Each panel is a heavyweight puzzle. Throughout the process, crews alternate tasks to maintain speed and accuracy, ensuring every panel meets design specifications. Even simple foam placement requires careful sequence to prevent gaps. Once installed, these panels serve as the backbone for warehouses and industrial buildings where insulation is critical. Step onto a sloped roof being transformed with 2 layers of insulation, creating a barrier that controls heat and moisture. Knauf Insulation introduces Unifit 32 mineral wool in a complete system designed for pitched roofs, combining diffusely open vapor barriers, ceiling components, and fitting accessories. The coordination of these components makes installation smoother and more reliable. The insulation is cut to fit precisely, aided by surface markings on the panels, helping installers align each section. Seeing these cuts in action is oddly satisfying. Unifit 32 stays in place without extra fixing, reducing the need for tying or additional anchors. This is why the work goes faster than expected. Roof insulation must be applied in at least 2 layers to bridge the thermal impact of rafters. The second layer fits within the steel frame of the drywall ceiling. CD profiles are installed 50 centimeters apart using either direct or rafter hangers. Seal LDS tape seals the UD profile to the gable wall, and the steel battens define cavities that will be filled with high-quality thermal insulation. It's clever how everything snaps together for a tight, consistent seal. If drywall boards are mounted directly over the inner vapor barrier, use Home's LDS 100 film carefully, laying strips without folds and sealing edges tightly against adjoining structures. Join individual film strips, adding grommets for cables passing through. Only after these steps can the drywall ceiling be installed, ensuring a complete, well-insulated roof system. This setup makes the whole attic feel more secure and cozy.
Woodland combines traditional veneer peeling with modern presses to achieve premium MDF quality. Logs are first peeled into veneers, then dried to achieve optimal moisture content. Glue is applied evenly before veneers are stacked to form MDF panels. You can feel the smoothness of these sheets before pressing NNN. The stacked veneers pass through hot presses, bonding layers under heat and pressure. Panels are trimmed and sanded to ensure precise dimensions. Machines equipped with automated cutters handle this efficiently, minimizing waste. Seeing those large panels slide under the cutters reminds me of giant paper folding and quality control stations inspect every panel for thickness, surface uniformity, and edge straightness. Defective panels are removed immediately, ensuring consistent product output. Finished MDF boards are then packaged and stored. It's neat how human supervision and machines coordinate so well in a busy factory. Every step emphasizes efficiency and material optimization, reflecting the advanced engineering workflow of Woodland. Operators adjust parameters constantly to maintain consistent product quality and durability. Follow each spindle pass as grooves and profiles form on the wood panels. The Holzer MULTIREX handles wood with unmatched versatility, processing panels for doors and windows with precision. Operators load each board onto the 5-axis CNC table, ensuring alignment for complex cuts. High-speed spindles glide across the surface, carving grooves, mortises, and intricate profiles. That cut looks cleaner than expected for such rapid movement. The control software adjusts each pass, compensating for material density and tool wear. Vacuum clamps hold panels firmly, preventing any shifting during machining. Feels like every movement is choreographed for speed and accuracy. Multi-layered operations are completed in sequence, from drilling to contour shaping, without manual repositioning. The system can process large format panels up to several meters long, handling both standard and custom designs. Safety enclosures ensure hands stay clear of the high-speed spindles, while monitoring sensors detect anomalies instantly. You'd never guess how much data and precision are packed into this setup. Once finished, the panels move to further assembly or finishing stations. With Holzer MULTIREX, industrial-level precision, speed, and flexibility come together, delivering panels ready for high-quality doors and windows with minimal manual intervention. Watch each brush as it's shaped, polished, and bristled by skilled artisans. Every ashwood handle at Tech is crafted with care. Operators select straight, defect-free wood, then shape it along traditional forms. Each handle is examined for smoothness before finishing. Natural rubber pads are attached to support bristles, ensuring flexibility and durability. The team applies tumble finishing with carnauba wax, giving handles a polished, protective surface. That finish lasts longer than you'd expect for handmade tools. Next, bristles are carefully inserted and aligned to maintain consistent density and spacing. Operators verify each row by eye, adjusting placement to achieve perfect balance. Simple mechanics, but serious attention to detail at work. Finally, combs and brushes are boxed and prepared for distribution. Every product reflects the synergy of Italy's natural resources and 4 decades of artisanal expertise. Feels like holding centuries of craft in a small brush. Logs several meters long are handled with precision for the Russian notch technique. The sturdy logs, naturally moist, are first inspected for straightness and knots. Each cut feels like controlling raw power, a true test of skill and patience. Operators choose the cutting angles based on the wood grain to reduce stress on the material. The craftsmen mark the sections to cut, ensuring the cup joints will fit snugly later. Marking also considers the eventual load-bearing points, crucial for long-term stability. The attention to detail here is intense. Every mark sets the tone for the whole structure. Using a specialized axe, each notch is carved, guided by centuries of knowledge in log construction. The cup's dimensions are verified against templates to maintain consistent interlocks. The unique Russian cup shape allows logs to interlock tightly, providing stability without modern fasteners. It's fascinating how such a simple shape locks an entire structure in place. After initial carving, the logs are adjusted for fit. Any minor gaps are smoothed with hand tools. Even small variations in notch depth are corrected immediately to avoid weak points. That precision looks almost too exact for handcrafting. The craftsmen rotate the log, ensuring uniformity in each notch. Throughout, care is taken to preserve the wood's natural moisture, which ensures flexibility during assembly and long-term durability. Logs are stacked temporarily to verify corner alignment before final assembly. Each cup joint is checked for snugness, and adjustments are made as needed. The process repeats log by log, gradually forming a perfect section of the log house. Didn't expect the Russian cup to hold so tight without nails. Finally, the prepared logs are set aside for assembly. The pre-cut cup joints make on-site construction faster and more efficient, while preserving the authenticity of traditional log building. Somehow, the logs seem to almost anticipate the builder's hand as they lock together. The process emphasizes both craftsmanship and technique, demonstrating why the Russian notch method has endured for centuries. The finished pieces showcase a blend of skill and tradition. Each log, from selection to precise cup cutting, is handled with care to ensure long-lasting strength and perfect fit. Each adjustment reinforces the principle that careful handcrafting outperforms hasty mechanical cuts. Even casual viewers can sense the expertise behind each movement, a legacy preserved in every Karelian pine log. Selecting containers GLDU 729341 and GLDU 729350, the team shapes each unit into a high Cube 1 mobile home. Engineers work with full-length timber beams and advanced tools to achieve structural stability. Over 100 meters of ventilation pipes are cleverly concealed in walls and floors. Flat roof trays with FPOM rubber and 5,000-liter capacities are installed, supporting sustainable building protection. Separate heating and cooling circuits optimize indoor climate. It's clever how they fit all systems into such compact spaces. Interior finishing follows, turning robust containers into functional, high-tech homes. Feels like living innovation packed into a single container.
Power-focused work demands tools built for tough material, and the Dorntech log splitter with winch enters the scene ready for heavy hardwood. Its hydraulic system drives the splitting wedge through meter-length logs, while the brass guides stabilize movement for long-term durability. Height adjustments shift in seconds, letting the machine handle different log sizes without delay. The speed jump after each reposition shows how responsive the controls are. The reinforced frame supports high pressure, and the separate oil supply keeps output steady. The two-hand control maintains safety, and the sudden snap when a knot gives is unexpectedly sharp. Choir mats from Coco HITECH's Ben Tray facility rely on tightly layered coconut fibers built for grip and durability. Workers feed sun-dried husk strands into pressing frames to lock each sheet. Then they guide each panel through heat setting to hold its structure, and that firmness hits stronger than you expect for pure natural fiber. Bundles are stacked for export, and the way the edges seal looks surprisingly bold for such simple material. What makes oak at Louis Latour bend so perfectly into a wine barrel without a single drop of glue? The atmosphere feels like a quiet workshop where precision guides every move. The process showcases how seasoned coopers shape oak into vessels that define the character of countless wines. Planks selected for quality are cut into staves with precise curves and angled edges that will align tightly without adhesives. The first task involves arranging these staves within temporary rings so their forms begin to lock together. As alignment improves, another ring holds everything firmly before the barrel moves toward heating. To prepare the wood for bending, the structure is lowered over controlled burners that soften the oak while gradually toasting it. Heat reshapes the staves, so the pulley system can draw the lower ends inward with steady force. You notice how the wood responds smoothly under tension, a reminder of the craft's resilience. Toasting continues until the desired internal char is achieved, influencing future flavor notes. Rings replace the earlier supports to maintain permanent compression, and their placement tightens the body into its final form. The entire frame almost feels alive as the heat changes the wood's tone. Grooves are cut near the top and bottom, so headpieces will fit securely. Workers check each joint closely, ensuring the curves meet properly before sealing. That level of care feels almost like the barrel is being tuned for performance. Dates and production codes are stamped once quality checks confirm accuracy. Another finished barrel moves down the line, ready to age wine with character shaped through human expertise and deliberate technique. Each completed piece reflects time, training, and the quiet certainty that skilled hands still guide the heart of this traditional manufacturing process. A quick look around ML Furniture shows how each workstation keeps the flow moving without pause, giving the factory a steady pace that pulls you right in. The organized layout makes it clear how each section supports the next without delay. The opening action places the boards across the guides so the saw can divide them into balanced sections. Each pass through the blades shows how consistently the material holds up under pressure. Workers select wide planks and arrange them so the cutting stations can produce consistent rectangular sheets for future furniture manufacturing. That steady feed into the cutter helps maintain uniform dimensions across the batch. You almost notice how the alignment stays steady even when the boards shift forward. Once cutting is done, the drilling unit drives its bits through each panel to create clean, aligned holes for later assembly steps. Operators position the sheets so the machine can punch every spot in the correct pattern. Seeing the rows line up so precisely reinforces how carefully the sequence is controlled. Those evenly spaced holes show how important accuracy is before any furniture build begins. Then every panel moves to trimming stations, where the edges are wrapped with protective edging material. Each trimmed edge shows how well the wrapping adheres when pressure is applied steadily. When the panels meet the target condition, they are stacked, wrapped, and prepared for shipment to downstream workshops. The final stacks show a clear consistency that reflects all the earlier steps working in sync. How does a firewood processor slice through logs this thick without slowing down? Operators push each piece forward with firm control, lining it up with a bar-length chainsaw, built for heavy-duty output. Some logs move through so smoothly that the pace almost feels unreal. The disc rotates with enough mass to maintain speed as it meets each incoming piece within seconds. The cut pieces slide into the splitting chamber where a hydraulic wedge presses through the grain, breaking logs into uniform segments. You rarely see a wedge drive through dense wood this quickly without hesitation. The processor keeps feeding and cutting in a loop that runs with consistent strength. A quick glance at the output stream shows just how rapidly the pile grows. In another setup, the machine tears through dense wood in one decisive motion, splitting sections that would take far longer by hand, turning them into coarse chips suitable for heating systems or mulch. The speed difference between manual work and this setup can surprise anyone watching closely. A log splitter equipped with a drill-shaped tip handles dense wood in a uniquely direct way. The drill-tip splitter drives its pointed head straight into the center of each log, pushing deeper until the grain begins to open. With steady pressure, the rotating tip forces the wood apart, creating a clean split without needing a traditional wedge. As the log widens, the machine keeps turning, peeling the halves away from each other in one continuous motion. The operator only needs to guide the pieces forward, while the drill does most of the work. On the larger end of the lineup, the heavy cutting unit uses a single solid blade. The log is pushed forward into the blade, and the knife slices straight across in one clean horizontal pass. The straight cutting blade gives a different tone to the work. The operator keeps each log locked under the guide bracket, while the machine drives it through, producing thick rounds that move on to splitting or milling. The frame barely shifts, which says a lot about how solidly the machine is put together. Seasonal operations rely on this type of equipment to meet demand across rural areas, where homes and small businesses use wood-burning systems for heat. The combined output of cutters, splitters, and loaders results in piles of ready firewood that keep production moving efficiently. You might find themselves surprised at how steady the machine stays, even during heavy loads. The entire setup shows how coordinated equipment can turn raw logs into heating fuel at a scale that supports full distribution networks. The scale of the forest operation becomes clear the moment the oversized logging truck rolls into view, built to haul volumes no standard unit could manage. This setup in Quebec's harvest sites shows how the off-road fleet moves timber straight toward the sawmill, following corridors cut deep into the forest. That first lift already hints at how much weight these machines can handle without hesitation. The grapple's reach looks almost endless when it swings over the truck bed. The operator begins arranging long logs using the large grapple loader, which includes an elevating cab that gives a wide view over the oversized truck. That height advantage saves a lot of guesswork when lining up such uneven logs. This elevated position helps keep every layer aligned so the truck can take advantage of its massive carrying volume, often reaching 100 to 110 cubic meters of wood. Seeing that volume stack up so quickly is surprising. Boards are placed using the big end/small end approach, letting the logs settle in a pattern that resists slipping as the stack grows taller. That alternating direction really gives the whole load a tighter feel. The way the grapple closes around each bundle almost feels like it knows exactly where to grip. That smooth clamp makes the whole motion look effortless. When the load needs extra stability, the operator may add a short cross log to reduce shifting. Once the bed is fully arranged, he drops a long trunk on the ground for a very practical reason. The driver will use it as a base to stretch the heavy chains across the top. Because the truck is enormous, the loader operator is the one who lifts the chains over the stack using the full-length trunk. That trunk works like a natural bridge for handling the heavy binders. Once the bed is fully arranged, he drops a long trunk on the ground for a very practical reason. The driver will use it as a base to stretch the heavy chains across the top. Because the truck is enormous, The loader operator is the one who lifts the chains over the stack using the full-length trunk. That trunk works like a natural bridge for handling the heavy binders. The driver picks up the transport slip, checks the tension points, and tightens the binders to secure the load. You can almost sense how solid those tension points become once everything locks in. The truck moves steadily along the designated route before reaching the checkpoint. Its pace stays controlled to ensure the load remains stable during the trip. Upon arrival at the checkpoint, the driver drops a copy of the transport slip into a sealed box for the Ministry of Natural Resources and Wildlife so the wood quantities can be tracked. This step confirms that the load has officially passed through the authorized control point. A quick move near the Luparca splitter shows how each log is guided toward the cutting zone with a steady push that feels decisive. The log slides into the cutter, and the single-stroke blade slices it cleanly into a uniform section. As soon as the cut finishes, the piece drops straight onto the splitting bed below. The wedge drives forward and forces the fresh block apart with steady pressure. Each split opens smoothly because the grain is already exposed from the cut above. The whole movement feels like a tight sequence, where cutting and splitting lock together into one flow. The operator keeps feeding more, keeping the splitter working without pause. Up to 300 millimeters of coconut non-woven thickness is formed on the Cormatex Lap Formair H line using horizontal airlay control. Coconut fibers gain a horizontal layout on the Cormatex Lap Formair H line, forming a stable non-woven path before bonding. Multiple bale openers loosen the blend, and powder resin is scattered for uniform structure. A thermobonding oven finalizes strength. Seeing the Aquila Power Catamaran form inside Sino Eagle factory feels like watching layers of structure appear out of nowhere. The hull sections are shaped from composite panels as teams secure layers that will support the vessel's stability. Bulkheads are aligned next, connecting major zones of the boat into a unified frame. Deck modules are lowered onto the structure so technicians can lock in joints for strength. Interior shells are positioned to form living spaces, and furniture bases follow in a steady sequence. Wiring teams run harnesses through channels before plumbing lines are set for long cruising. Cabin detailing continues with fit-out panels that add function throughout the boat. The exterior receives layers of fairing and sanding so the surfaces stay clean for final coatings. Engines are mounted, linked to fuel and steering systems, and tested under controlled loads. When the Aquila 40 rolls to inspection, every station verifies alignment, sealing, and component fit. That structure looks like it's ready to take water miles. Someone seeing this for the first time might gasp when the cabin shell settles onto the hulls. Large volumes of recycled wood at ARAUCO's facility are broken down, so their fibers can be regrouped into particle board panels. The line starts by receiving 100% recycled or recovered wood fiber. Wood particles are blended with resin, forming a consistent mat that moves forward for consolidation. How tidy that mat looks before pressing. Heat and pressure solidify the board as the resin bonds everything into a dense core. After cooling, trimming, and sanding prepare each sheet for the decorative stage. A resin-infused decor paper is fused directly to the panel, creating Prism TFL with durable texture and reliable surface performance. That snap of the laminate setting feels unexpectedly bold. These panels support cabinetry, fixtures, and interior projects with dependable quality drawn from controlled fiber sources.
Deep in Anhui, China, Gala Manufacturing turns FSC-certified bamboo poles into elegant flooring with remarkable speed. The bamboo is first split into long, uniform strips by industrial splitters designed to handle the dense, tall culms efficiently. That split is cleaner than expected for such tough bamboo. Once split, the strips enter rapid kilns, where precise drying removes excess moisture while preserving natural flexibility. That speed alone could catch anyone off guard the first time. After drying, each strip is planed and sanded to exact dimensions, smoothing the fibers for the next step. Operators guide the strips into a cold press gluing line, applying eco-friendly resin and compressing them into stable panels. The panels slide into the press with an almost effortless flow. These panels are cut into planks, each milled with tongue-and-groove joints for seamless flooring installation. Next, planks receive a protective UV lacquer coating, enhancing durability and sheen. Gala's inspection team carefully checks every plank for warping, splits, or uneven surfaces. Once approved, the boards are packed into FSC-labeled crates, ready for shipment while keeping sustainability at the forefront. Feels like holding controlled power in motion. That pull is stronger than you'd think for a mid-size machine. Every stage balances speed, precision, and care, from splitting to pressing to coating. The plant's proximity to the bamboo forest ensures fresh material is always processed quickly, preserving quality. This combination of traditional bamboo resources with modern industrial machinery makes Gala's flooring not only practical, but striking. That finish is smoother than you'd expect from plant fiber. Bamboo strands are soft, but the press makes them unyielding. Each strand is weighed to ensure the final density reaches 1,150 to 1,200 grams per cc. The weighted bamboo strands are then loaded into an industrial press capable of 500 tons of pressure. That press looks like it could flatten anything in its path. After pressing, the boards emerge hot and dense, ready for weaving into rough strand panels. Feels like squeezing the forest into a board. Logs are heavy yet assembled with surprising ease by skilled crews. Delivery and unloading of the house kit mark the first tangible step, with each log inspected for damage or warping. Even the smallest twist in a log can change the whole structure. The foundation is treated with waterproofing to ensure longevity before the first crown of logs is placed. Crews fit insulation between logs to keep interiors warm and airtight. Next, beams for the second floor ceiling are installed, providing support for the upper structure. These logs look like they could hold a small army. Assembly of the second floor continues with attention to alignment and stability. The gables are then carefully cut and adjusted for the roof installation. Who knew cutting gables could feel so satisfying? Every log placement is measured to maintain straight lines and structural integrity, reflecting both craftsmanship and planning. After 2 weeks of intense work, the log frame is ready for roof installation. Seeing the frame stand tall like this is honestly a bit thrilling. HAB techniques ensure precise joining at corners and intersections, while minor adjustments are made to accommodate settling. By following a clear sequence of unloading, waterproofing, crown placement, insulation, ceiling beams, second floor assembly, and gable cutting, the house is prepared for roofing. Even after all this, you can still feel the weight of each log pressing down with purpose. The veranda of a log house in Crescino takes shape as vertical posts are installed with precision. Each post is checked carefully for level and alignment. Compensators for shrinkage are positioned atop the upper beams to ensure future stability. Workers mark the top logs thoroughly, preparing for their secure placement. Even the smallest misalignment could affect the entire structure. Posts are mounted one by one, with constant attention to measurements. This methodical approach makes the frame both solid and adaptable. Construction continues with care, blending tradition and modern log building techniques. The abrasive discs on Dubke's sanding station strip away old layers efficiently, enhancing wood quality. This step really highlights how much work goes into restoring each log. The nylon brushes and abrasive discs remove the darkened layers efficiently, revealing the wood's natural tones. Workers handle the corners and hard-to-reach areas with care, switching to coarser P60 discs for tougher sections before finishing with P80. That attention to the grain makes the timber look refreshed without losing character. Sanding evens out color and eliminates nearly all visible defects, though fine irregularities remain naturally. Crew members continuously adjust pressure and angle to maintain consistent results. It's neat how the P80 finish brings out the wood pattern subtly. The process preserves the timber's inherent properties while enhancing its quality. Even tricky spots are addressed methodically, leaving every surface balanced and visually harmonious. The care in each step really pays off in the final appearance. How does a nylon brush reveal such sharp grain on solid logs? Before this final brushing, mechanical flaws and resin pockets are removed using flap discs. Corners and hard-to-reach areas get careful attention, ensuring every surface is smooth. The process starts with a coarse P46 nylon brush on stubborn logs, then shifts to P80 or P120 for the final polish. You can almost see the wood pattern emerging in high contrast. It takes slightly more time than sandpaper, but the visual depth is unmatched. Didn't expect such a fine detail from these brushes.